Hello, and welcome to Backer Breaks It Down. In this episode, we look at properties of isosceles triangles. We're specifically going to look at something called the isosceles triangle base angles theorem and its converse. So, an isosceles triangle is a triangle in which at least two sides are congruent. We call the congruent sides legs. The base angles are opposite these legs. So if I were to start here at this leg and draw an arrow, it's pointing to one of my base angles. Do the same thing with this leg, go directly opposite it. There's my other base angle. Okay. And in case you have any questions about opposites, they're illustrating here that angle A is opposite side BC, and that angle B is opposite side AC, and then obviously angle C is opposite side AB. So that's what we mean when we say opposite, okay? So the isosceles triangle base angles theorem says, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in this triangle here, we know that AB is congruent to BC, which means that the angles opposite those sides are congruent. So in short, if I have a triangle with congruent sides, then the base angles are congruent, okay? So if we take a look at the example on the right, it says set up and solve an equation to find the value of x and then find the measure of angle f. Well, I see those tick marks here. Remember, these tick marks indicate that those two sides are congruent. And according to the base angles theorem, I know that the angles opposite those sides are also congruent. So that means that angle E is congruent to angle F. And if angle E is 3x degrees, well, that just means that angle F is also 3x degrees. So then I can use the fact that all three angles add up to be 180 to write an equation. So I can be like 42 plus 3x is equal to 180 degrees. Combine like terms, and then go about solving this equation for x. So ultimately, I get that x is equal to 23. Remember, in geometry, x is oftentimes not the final answer. They want you to do something with it. And here they want us to find the measure of angle f. So the measure of angle f is equal to 3 times x. Remember, they told us that. Do the math, we get that f is 69 degrees. So this is the isosceles triangle base angles theorem. If the sides of a triangle are congruent, then the angles opposite those sides are congruent as well. The converse switches this around and says if the angles are congruent, then the sides opposite those angles are congruent. So in short, if you have a triangle with congruent base angles, then you can say these sides are congruent. So if we look at the example on the right, these arc marks here are indicating that angle T is congruent to angle S. So what that means, according to the converse of the isosceles triangle base angles theorem, the sides opposite those angles are congruent. So in this problem, that means RS is congruent to RT. So I can use that relationship to create an equation. I'm going to have 1.5 times y equals 2y minus 4.5. And then I'm just going to go about solving this equation for y. and I ultimately get that y is equal to 9. It says to find the measure of RS. RS is 1.5 times y. So since I know that y is 9, I can do that calculation, 1.5 times 9, and I get that RS is 13.5. So these are our theorems associated with isosceles triangles. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. And that's how Backer breaks it down.